Alright, welcome back everybody to the final part of circuits. We're going to be talking about circuits where resistors are both in series and parallel, not serial. And we call that in combination, probably the most difficult part of this, but shouldn't be too bad, hopefully. We're just going to be doing a little bit of this because it's the more difficult part of this unit. Alright, here we go. Okay, look at the diagram to the right. What is the combined resistance of R2 and R3? Okay, so we are doing R2 and R3. What's the combined resistance? We should know that these resistors follow the same path of the current. So that means they are in series with one another. So all we have to do is add them. So it's going to be 15 plus 10. So this is just going to be 25 ohms. Okay. Now part B says, what is the total resistance of the circuit? What I'm going to do is I'm going to redraw this. So I have 12 volts. Then I have them going up like this, then like this. And then we have that. That one is 20 ohms. And then I'm going to redraw this one over here so that these two are already combined. And we already calculated that. We know this is 25 ohms. And then come back, go like that. Okay. Now it's going to be a little bit easier for me to find the total resistance. I just have to do these two in parallel with each other. So I know that for part B, 1 divided by the resistance total is going to be equal to 1 divided by 20 plus 1 divided by 25. I'm going to put that into my calculator. 1 resistance total is equal to 1 divided by 20 plus 1 divided by 25. And I get 0.09. I'm going to put both to the power of -1 so I can flip it. And then I can find the resistance total. And that's just going to be 11.1111 ohms. Okay. Now part C is, what is the total current? So I have the resistance total, I have the voltage total, and now I should be able to find the total current relatively easily. We're just going to be doing Ohm's law. V equals current, voltage equals current times resistance. So total voltage is 12, total current is what we're looking for, total resistance is 11.11. Simplify this. Current is equal to 12 divided by 11.1111. And let's see what we get. We get 1.08 amps. Alright. I know I broke it down simply, but it could get a little confusing. Take your time doing it and make sure it makes sense. We're going to do one more of these and then we're going to finish up. Look at the diagram at the right. A, what is the total resistance? B, what is the total current through the circuit? Alright, and then we have C, what is the voltage drop across R3? Alright, total resistance. First, what I'm going to do is I'm going to break these two down to find out what the resistance is when you add those two together. So since the current is splitting off, that means they are in parallel with each other. So I'm going to be doing 1 over, I'm going to just call it resistance total, is equal to 1 divided by 3 plus 1 divided by 6. And then let's see what we get. 1 divided by 3 plus 1 divided by 6. And we get 0.5. And then I'm going to try to find the inverse of this so I can find what the resistance total is. So I'm going to put this to a -1, power of -1. And we get, this is 2 ohms. Okay, that's not what the resistance total is. That's just what this is combined here. Okay, so I'm going to redraw this to help me find the resistance total. I'm going to draw it over here, 18 volts, and I'm going to go like this. And I found the combined this, that's 2 ohms, so I'm just going to put that there. And then this over here is 4 ohms. Okay, so now I see this and this are in series with each other, so I could just add them. So 2 plus 4 is equal to 6 ohms. Okay. Part B is what is the total current. So since I already know the total resistance and the total voltage, I should be able to find the total resistance, no problem. Voltage equals current times resistance. And if we're looking for current, I can manipulate this with V over R. So we get 18 divided by 6. And I know what 18 divided by 6 is. That's just going to be 3 amps. Okay. Okay, great. So what is the voltage drop across R3? So we're going to go back over here and we'll look at this. We see this is 4 ohms. And we want to know what the change in the voltage is. But we need to find what the current is over here before we can find this. So we know the total current. So there's going to be 3 amps of current going through. 3 amps. And then over here it's going to split. So some of them is going to go down this way. And some of them are going to go up this way. We can calculate it, but we don't need to right now. Because we know when it comes back over here, it's again going to be 3 amps. So we know this is going to be 3 amps. So now that we know this piece of information, we can find the voltage. So I'm just going to write V3 is going to be equal to current 3 times resistance 3. And we can just plug things in. 3 amps times resistance 4. And this is going to be 12 volts. Right? Alright, I hope that made sense. That's everything that we're learning with circuits. Watch it back because this is the hardest part. So if you were confused, totally makes sense. Thanks for watching, everyone. Bye.